Hello, and welcome to the latest update on my university project, Open Vehicle Diagnostics. Firstly, the app now has a cool looking logo and a much cleaner interface design. This design is loosely based around Google's material guidelines and has a much more pleasing look compared to the stock design of the UI library I am using. As part of this new interface, I built a theme engine which has the ability to toggle between light and dark mode. I'll leave dark mode on for the rest of the video because in my opinion dark mode is far superior to light mode. The UDS scan mode has been redesigned and supports saving the results of the scan to a JSON file. The entire process uses a more polished UI and is slightly faster, however I will speed this footage up for completion. Once the scan is completed, you can now save the results to a file, which you can edit to fill in extra details about ECU names if you know those details. Here I will now open the save file for my own car which I have previously generated and filled in. Here you can see I can select an ECU to establish communication with for a diagnostic session. This has been the main focus of the week, and I shall now demonstrate which features the diagnostic session mode currently has. To begin, let's establish a connection with my engine's ECU. From within the diagnostic session I can request detailed information about the ECU using Keyword Protocol 2000 over CAN bus. As seen here, the diagnostic information tells me the part number of the ECU as well as the hardware and software versions running on it. This also tells me the diagnostic version running on the ECU. Think of this as the diagnostic specification defined by the OEM which the ECU supports. I can also request detailed ECU trouble codes, which are the ones not found in the OBD2 specification, and are instead defined by the OEM for each ECU they produce. In this output, the ECU has two OEM error codes, 2509 and 2211. I can also view the details about each error. This field tells me if the error code is present in the ECU's volatile memory. This field tells me if the error code is present in the ECU's non-volatile memory, meaning the ECU has permanently logged the error code. Lastly, this field tells me if the error code has triggered the check engine light to come on in the car. With this button, I can tell the ECUs to clear the errors. Doing a rescan shows the errors are now gone. To really prove this system is better than a generic OBD2 scan tool, let's establish communication with the transmission ECU in the car. Here I can ask it for details as well and ask it for any trouble codes. Luckily, this unit has not logged any error codes. And now for some fun. I will attempt to force the check engine light to come on in my car and then use my own scan tool to clear those trouble codes. So we currently have 1, 2, 3, 4 items unplugged on the engine. Let's see if it triggers a check engine light. Really? Okay, and after restarting the engine, it's now gone into limp home mode with a check engine light. Let's see if we can scan and clear those. So with a check engine light present, let's read the error codes. Post-processing Ash here, just forgot to mention in this clip that this error code, 0105, is what is causing the check engine light to light up, whilst the other error codes present do not cause the check engine light to come on. Okay, still currently the same error code, and let's clear and see if the check engine light goes away. There we go. Perfect. Read error codes again. No errors present. Cool. Well, I hope you enjoyed that. As usual, I'll leave all the source code links in the description. Like, comment and subscribe, and I'll see you in the next one. Goodbye.